So our homework for today is the Am I Ready page from Chapter 9, page 607 and 608. If you already did it, you could just check your answers and you could color them at the bottom to see how many you got right. So first thing I am going to do is write each fraction in simplest forms. So I'm going to find out what number they have in common, right? I'm going to say 4 and 8. So 4 is 2 times 2. And 8 is 2 times 4, which is also 2 times 2. I'm going to get rid of the ones they have already, right? I'm going to get the ones they have in common. So they both have 1, 2, right? 1, 2 in common. I'm going to get rid of that one. So I don't multiply both of them, right? There's different ways I could do it. I'm going to say 2 times 2 is 4, 2 times 2 is 4. The number that they have in common is 4. So I'm going to divide my top by 4. And whatever I do to the top, I have to do to the bottom. So 4 divided by 4 is 1, and 8 divided by 4 is 2.
It's 11.
It is 11. So you can go. I'm just doing math homework. All right, so here is 4 divided by 12. I'm going to find out what numbers they have in common, right? 4 could be 2 times 2. 12 is 2 times 6. Oops, sorry, 2 times 6. And 6 is 2 times 3. So I'm going to say they both have 2 2's in common, right? I'll cross off that one because they both don't have that. They both have the 2 2's in common. 2 times 2 is 4, so I'm going to divide by 4. Divide by 4, divide by 4. Whatever I do to the top, I have to do to the bottom. 4 divided by 4 is 1. 12 divided by 4 is 3. So my answer is 1/3. All right, my next one, 15/20ths. These are a little easy, right? I can see, 5 would go into both numbers. So, yes, question? All right, so I know I got to slow myself down. All right, so my next problem is 15/20. So hopefully you guys could see that both of these numbers are divisible by 5, but if you don't know, I can just break these numbers down into their smaller numbers into their prime factors. 15 is the same as 3 times 5, and that's as small as those will go, right? 20 is the same as 4 times 5, and 4 is 2 times 2. And I look what the biggest number they have in common here, the 5, right? This one does 3's, 2's, they both have a 5 in common. So 15 divided by 5, I'm going to divide by 5 on the top and the bottom. So 15 divided by 5 is 3, and 20 divided by 5 is 4. So it's equal to 3/4. One, so I have 4/24. So hopefully, right, you could see 4 goes into 24. 4 times 6 is 24. But if you don't know, you can still just make them go smaller, right? I make them small numbers. 4 is 2 times 2. And 24 is 2 times 12. And 12 is 2 times 6. And 6 is 2 times 3, so I just make them in their smallest forms. And then I see what they have in common. They both have 2 2's. Right, this one has 3 2's, so I'll get rid of it. And a 3, I don't need that. But they both have 2 2's. So I'm going to say 2 times 2 is 4. I'm going to divide the top by 4 and the bottom by 4. Oops, now I have such a mess. 4 divided by 4 is 1, and 24 divided by 4 is 6. So 4/24 is the same as 1/6. Hardest one on this page. Sorry, hopefully you can see my answer there. That's my answer. All right, I'm going to do my next one now. Ooh, I didn't stop recording. Okay, 24/40. So I have to see what they have in common. So, right, there's a bunch of different ways to do it. I instead of writing them all out, because sometimes like 40, I'm going to have a lot of factors there, right? I just like to do it this way. I'm going to say 24 is 2 times 12, and 12 is 3 times 4, and 4 is 2 times 2. So now I have 2 times 3 times 4 times 2 times 2 would be 24. Those are my factors, my prime numbers. I'm prime factorization. So 4D is 4 times 10, right? And 4 is 2 times 2, and 10 is 2 times 5. So now I'm going to find what numbers they have in common. They both don't have a 5, and but this one has 3 2s, and this one has 1, 2, 3 2s. So they both don't have a 3, but they both have 3 2s. And 2 times 2 times 2, right? 3 2s is 2 times 2 times 2 is 8. So I can divide my top by 8 and my bottom by 8. 24 divided by 8 is 3. And 40 divided by 8 is 5. Because 5 times 8 is 40. 3 times 8 is 24. So number 6 is going to be 3/5. I have 4/16. So Marcella made 4 out of 16 of her free throws, right? She's playing basketball. She's making 3 free throws. She made 4 of them. She tried 16, but only 4 went in the basket. Write the fraction of free throws she made in simplest form, right? I know how to do my fraction now. She made 4 shots out of 16 she tried, but it's making it in the simplest form, right? So I could take my 4, and hopefully you guys could see already, right? 4 goes into 16 and 4. 4, so I could do this if I don't know, but if I already see that, I know 4 times 4 is 16. I could see right there. So I know I could divide my top by 4 and my bottom by 4. And 4 divided by 4 is 1. And 16 divided by 4 is 4. All right, so here's our next problem. It says, write each improper fraction as a mixed number. I don't remember doing this in our book, but maybe we did it just real quick there. So I need to write these improper fractions as a mixed number. There's different ways to do this, right? This is an improper fraction because the number on the top is bigger than the number on the bottom, right? So if I have 7 out of 7, I know I have 1 whole. There's a lot of different ways to do this. So I'm going to say 7 out of 7 would be 1 whole, and then I'd have 3 more, right? Because 3 plus 7 would be 10. So this is going to be 1, and I'm still going to have out of 7, I'm going to have 1 whole piece plus 3 more out of 7. And we will do this problem. I'm just going to do it a different way. Well, I'll do this one a different way. This one's same thing, right? Hopefully you could see that I have 2 out of 2 plus 1 out of 2 here. So I have 2, I really have 3 out of 2. I have more than 1 whole. So I have 1 and 1/2. Because I turned this one into 1. That's what I did here too, right? 10 out of 7 would be the same as 7 out of 7 plus 3 out of 7. And my answer, 1 3/7. There is a different way I could do this though, which I prefer this way because I have to like think and add, but I would just do this way. 14 out of 6, I would do it like this. I would divide, right? I'd say when I write my fraction, right, it's just a division problem. It's 14 divided up into 6. So 6 goes into 1. No, 6 goes into 14. Yes, 2 times. I go 2 times 6 is 12. I subtract. I have a remainder of 2. right? But when I when I have a remainder and I'm dividing by something, all I do is I say 2, I put my remainder on the top, and I was dividing it up into 6. So now my answer is going to be 2 and 2/6. But hopefully you could see 2/6 is going to be the same, right? I divide my top by 2, my bottom by 2. This is where math starts. They're like, oh, it starts getting really hard. 2 divided by 2 is 1, and 6 divided by 2 is 3. So my answer is going to be 2 and 1/3. It's just a lot of steps in math, but it's the same thing we've been doing, but just a different way. All right, so I'm going to do this one the same way, 22/4. So I'm going to take, right, this means 22 divided by 4. If I write this as a problem, right, I would write, where could I write it? Over here. 22 divided by 4. Right, I put my 22 inside the house and I divide it up by 4. So 4 goes into 2? No. 4 goes into 22 5 times. Because 5 times 4 is 20. I subtract, I get a remainder of 2. So I write my 2 on the top. I could keep dividing, right, and do decimals, add a period, 0, and right, because any fraction is the same as a decimal. It's just a different way of writing it. This is going to be 5 and 2/4. But hopefully you can see 2/4. If I divide the top by 2 and the bottom by 2, I will end up with 5 and 1/2. 2 divided by 2 is 1. 4 divided by 2 is 2. Right, and I could do this back to, if I want to go to this way, right, I could say, ooh, 7s, right, I'm going to go, okay, 7 plus 7, it's going to be 7 on the denominator. 7 times 5 would be 35, right? 7 times 4 would be 28, right? That would work. So I could put my 28 over here, 28 sevens. And then I know I need 2 more 7s here. I'm just doing it a weird way so you can see, right? 28 plus 2 would be 30, so this is still 30/7. 28/7, right? 28 sevens would be 4 7s, because 4 times 7 is 28, right? I'm just taking 28 and dividing it up by 7. 4 times 7 is 28. Or I'm using my math fact, right? 7 times 4 equals 28. So my answer is going to be 4 and 2 7s. There's a lot of different ways I can do these problems, right? 41/8. Right, I know 40/8 would be 40 divided by 8, 5. So I could see 5 and 1/8. So there's just different ways I could do it. I'll do it this way. I'll do 41 divided by 8. 8 goes into 40. 1. 5 times. 5 times 8 is 40. Subtract, I have 1. 5 and 1/8. So that's my answer. 5 and 1 out of 8. All right, number 14. A recipe for potato casserole calls for 7/4 cups of cheese. Write the fraction as a mixed number. So this is when I would probably, because it's just a small number, I'd say 7/4 is going to be the same as 4/4 plus 3/4. Right, 4 plus 3 is 7/4. So I'm going to say 4/4 is 1. So I'm going to say 1 and 3/4 cups of cheese. All right, so on the back, I got word problems. I shouldn't have written in the marker. It always goes through. So here's my words, not word problems. I have vocabulary problems. So I need factors, least common multiple, greatest common factor, mixed numbers, multiples. So I have to tell which is which here. So I can see 9 and 12 blank of 9 and 12. And it shows me the 3's are what of 9 and 12? I can see the 3's are both factors of 9 and 12, right? 3 times 3 is 9. 3 times 4 is 12. So 3 are both factors. I multiplied together two factors. A factor times a factor is a product. So, right, this is 3 times 3, they're both factors. 3 times 4, they're both factors. Oh, I should have put an S at the end. And up here they had an S also. All right, here, 9 and 12. So I could see 9 and 12, and then I see they circled the 36 here, right? What are they doing here? They're counting by 9s. 0, 9, 18, 27, 36. 12, they're counting by 12. 12, but they both have, a common multiple, right? These are the I'm multiplying here. I'm adding, so I call these my multiples. And now they're asking me, what did they do here? What do the circled numbers represent? They represent the greatest common factor. That's why they're circled, right? They're looking for what factor these two numbers have in common. They both can be divided by 3, right? If I was reducing my fractions, I'd want to do that. If I'm trying to make my fractions smaller, I'd want to do that. When I want to make them bigger, so I can make my denominator bigger, right? So I can compare, so I can add them or do work with them. I look for my smallest common multiple, the number they have in common that's smallest. So this is called my least common multiple. And I can abbreviate this, right? This is GCF, or this is LCM. And how can greatest common factors and least common multiples help you work with fractions? I'm going to say they help me find equivalent fractions they help me find the equivalent fractions. The next thing they do, they help me add or subtract fractions. So all kinds of things, right? I can do with when I know these. I can find I can find equivalent fractions. It helps me add and subtract fractions. It helps me simplify fractions. And so I'll say or help simplify. Or help simplify fractions.